This question is a little bit more complicated. It's still pretty straightforward, but we're going to have to do a bit more legwork. 5.1 grams of sodium hydroxide are dissolved to make a 203 milliliter solution. What is the solution's pH? Now, key important thing to notice here, we have a base in our sodium hydroxide. We are being asked to calculate its pH. We cannot calculate the pH directly from the concentration of the base. You can only calculate the pH directly from the concentration of an acid. So what we're going to have to do here is we're going to have to calculate the pOH first and then use that to figure out what the pH would be. So we're going to have to solve for pOH first off. In order to get pOH, we need to know what the concentration of the hydroxide ions is in moles per liter. We are told we have a volume of 0.203 liters. We have a molar mass of 40 grams per mole, which we can calculate from our periodic table. And we have a mass of 5.1 grams. As well, this is sodium hydroxide, so it's NaOH. The concentration of NaOH will be equal to the concentration of OH minus, because there is only one hydroxide ion in NaOH. So in order to do these calculations, we need to do a bit of unit canceling. I want moles per liter in the end. I have moles already, but they are on the bottom of my molar mass, so I have to flip it upside down in order to get them onto the top. So we have 1 mole for every 40 grams. I want to put liters on the bottom of my final answer. So I'm going to flip my liters as well. Remember, that's the exact same as dividing by liters. And then to cancel out my leftover grams, I'm going to put 5.1 grams on top. This is going to give me a concentration of 0.628 moles per liter. So, decently concentrated solution. Next, I need to calculate my pOH. pOH is equal to the negative log of the hydroxide ion concentration. So that will be the negative log of 628 thousandths of a mole per liter. The pOH then is going to be equal to 0.202. That number's rounded off. Remember to use all of the digits that you get in your calculator. Then to figure out the pH plus pOH always equals 14. So pH is equal to 14 minus pOH. In this case, that means 14 minus 0.202. That gives us a final pH of 13.80. Remember, in this, we're having two significant digits. The two significant digits in a pH value come after the decimal point. We have two significant digits because we had two significant digits in the mass we used in this calculation, 5 and 1/10. So that means that we need two spaces after the decimal place in the pH. Even though there's 2 place values here, neither of those are significant. And actually, the 13 in front of the decimal is no more or less significant than a 7 in front of the decimal, because both of them, again, are not conveying value and measurement. They are conveying magnitude. How big is the scale of this number, or how small is the scale of this number? The actual content of the number as it is, the measurement of the number is done by the numbers after the decimal place, because we have run this through a logarithm.